Hi everyone. This is my demonstration of the closest pair of points algorithm analysis implemented in Python. You can see here in this Jupyter notebook file, I have implemented the brute force algorithm with O n square time complexity and divide and conquer algorithm with O n log n time complexity to find the closest pair of points in a 2D plane. Since it is a Python in Jupyter notebook, we don't need the compilation. We just execute the cells directly. Let me quickly show you the structure of the implementation. Here's the brute force closest pair function, which examines all possible pairs of points, and here's a divide and conquer closest pair function using recursive splitting. This closest pair recursive function implements the recursive divide and combine logic of divide and conquer method. The create unique points function generates random unique points for our test. Now let me verify correctness with the sample standalone test. This is a sample standalone test. By just choosing four random points, we are going to execute this, and over here we have the output. So upon checking on this, according to the theoretically, the distance between 2 points should be under root, which is 1.414, and which satisfies. Distance agreements also pass. So we can see both the algorithms works perfectly fine. Now, let's go back to the main code. Okay, coming here, now let's see full empirical analysis. I've already generated the output before as it takes a long time to this output to get generated. So let's see what's in the output. The results are in a summary table. For brute force, O n square at 10,000 points, it takes around 21 seconds. At 25,000 points, approximately 130 seconds. At 55,000 points, about 687 seconds. Notice the dramatic quadratic growth. For divide and conquer O n log n at 10,000 points, it takes 0.14 seconds. And at 25,000 points, it takes 0.44 seconds at 55,000 points. Much more efficient scaling. Look at the speed up analysis table. Lines once at 10,000 points, it's 150x faster. At 25,000 points, it's 295 times faster. And at 55,000 points, it's much more faster. This perfectly demonstrates the difference between O n square quadratic complexity and O n log n linear arithmetic complexity. The additional tables from closest pair of points problem show empirical running times, theoretical predictions using fitted constants. Conclusion: to summarize what we have demonstrated today, first, both Python algorithms in closest point of pair problem successfully on sample test cases and large datasets producing correct results. Second, I showed you in the second code in this file how we generate points once per iteration using create unique points, and both algorithms receive the exact same time for fair comparison. Third, we run test 10 times, calculate averages by summing times and dividing by m as shown. Let me just run this file so that we could see what happens. So it started generating the file, so it's gonna take 10 iterations every time. So the results clearly validate our theoretical analysis brute force exhibits quadratic growth while divide and conquer scales with O n log n, making it vastly superior for large datasets. Thank you for watching.